All right, so talking about the triangle inequality theorem today. And basically, this is really kind of a neat concept. Can you make a triangle out of side lengths of any size you want? So in other words, could I take triangles, let me get out some of my sticks here. Let's say I had, I need a, that's the one I need, right? Oh, I guess there's not one of length 2. That's weird. Let's just take these 3 random stick lengths. And we'll do pink short. Yeah. Oh, no, I already have that one. I guess green. Okay, say I had these 3 lengths. Can I make a triangle out of these connecting end to end?
Yes.
You think I can?
Possibly. I don't know. I haven't seen them lined up yet.
Maybe yeah, you're right. I don't know. Maybe I can, maybe I can't. So that's kind of my point. If I had any 3 side lengths, so maybe let's swap out the green one for this orange one. Could I make a triangle end to end out of these 3?
No.
Probably not, right? So where's that limit? When can I and when can't I? So let's go back to the first 3 that I had and see if I can actually do it. So if I connect end to end, can I actually do it on this one? I can. It's just a really teeny tiny triangle, but it counts. So that one worked. I was able to make a triangle out of those 3. And then I had swapped the green with an orange piece. So let's try that. So these 3, there's just no way to connect them end to end. There's nothing I can do. It's never going to reach. So if I have these set 3 side lengths, I just can't make a triangle out of them. So there's a limit. There's only so many lengths that I can sort of put together and actually make a triangle. So that's what the triangle inequality theorem is all about. It helps us figure out what side lengths will make triangles and which ones won't. But before I tell you it, I want you to see if you can figure it out. Let's say I had 2 side lengths of, if a triangle has 2 side lengths of, let's say 3 inches and 5 inches, what could the third side be? Or let's say, what lengths could the third side be? So think about that for a minute. I have a triangle. I have 2 sides that are 3 inches and 5 inches. Let me see if I have any sticks that are actually, or 3 inches and 5 inches. Let's see if I have any. Yes, green is a 3 inch. And let's see here. Yellow's 4.5. Let's see. Red is shorter. Yes, perfect. Purple is 5 inches. Okay, so if I have these 2 side lengths, what are the lengths you suppose the third side could be? Anybody give me one length that you think would work?
Either 4 or 6.
Okay, so let's try it. I'm actually going to measure this out. So hold on, let me put all these back in the bag before I spill them everywhere. Okay, so let's go with 4 inches. So there's my 2 sides. And let's measure out if I could have 4 inches. So there's 4 inches on my protractor from the edge to my thumb. So let's see if that would work out. And it would. So there I am able to create a third side that's 4 inches long, and it works from end to end. So let me zoom out a little bit more so you can see the whole triangle. Yeah, so 4 inches works. And then what was your other guess? 6?
Yeah.
All right, so let's see. 6 is the whole length of the bottom of this protractor. So can I do it? Yes, I can. So 4 and 6 both work. So let's make a list of what works. 4 inches, 6 inches works. Let's have a doesn't work. Give me a value you absolutely don't think would work.
0.
0, yeah. Because how could you have, you're right. 0 is definitely not going to work. You can't have a side length of 0, so. Okay, any other guesses on either works or doesn't work?
Negative numbers?
Yes, I certainly can't go negative. So let's put any negatives over here. All right. What else? Anybody have another guess for works or doesn't work?
Anything, I don't know, past, I guess, any number bigger than like what works, I guess you could say. I don't know.
You're right. There's eventually going to be, let's just pick a really big number, like, I don't know, let's say 15. There's no way, if this is 3 inches and this is 5 inches, and of course I don't have a ruler, all I have is my protractor. But hold on, I can put 2 protractors together. So 2 protractors end to end is 12 inches. There's no way, so let's even just pick 12. There's no way that I can connect end to end here. It's just not going to reach. You see that? So 12 inches, there's no way. In fact, actually, look at where we're at. If this is perfectly flat, then this is going to be 8 inches, right? Because I have a 3 and a 5 inch. So that's 8 inches is perfectly flat. I wonder if 8 has something to do with this. But 12 certainly does not work. 12 inches would be way too big. So let me ask you that question. If one side is 3 and one side's 5, could the other side be 8?
No.
Haley says no.
Maybe.
Anybody else want to weigh in on this? If I have side lengths of 3 and 5, could the third side be 8? Oh, James says yes. Anybody else want to give their thoughts here? You've got one side 3, one side 5. Could the third side be 8? So here's the problem. If I lay this out, right? If this is 3 and this is 5, that makes 8 altogether. So the third side of the triangle being a stick that's exactly 8 inches long, I can't make a triangle out of it. It would just, the best I could do is make a straight line. But I can't have a straight line. I need a triangle. So that means if I'm going to pivot this in, now this is going to be something a little bit less than 8, right? Because perfectly flat is 8. So if I sort of bend it up a little bit, now it's starting to get a little bit smaller, 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 smaller still. So 8 is sort of my cutoff point. I can't have exactly 8 because it would just make a straight line. But it looks like I can, once I start making it a little bit smaller than 8, I am able to connect that third side. Okay, so as I shrink in, I can do less than 8. However, can I do any number less than 8?
Yeah.
So let's add to our list. Doesn't work. 8 inches didn't work. Okay, so now Haley, you say yes, any value less than 8. What if I had 3, 5, and let me actually see, I might have one. I want one that's 1 inch long. Close enough. This one, it's a little bit more than 1 inch, but that's okay. Could I make a triangle out of these 3 pieces?
Yes.
Let me try.
Never mind, I changed my answer.
Yeah. So turns out that, yeah, I need something less than 8, but I can't go super small because it still doesn't reach. That third side needs to be a certain length in order to get all the way over to here. So where's that cutoff? So there's 1 inch. So 1 inch definitely didn't work. Could we try 2 inches? Let's see. I'll see if I have a piece that's 2 inches. I don't actually think that I do, but I can just measure it. No. Darn. Okay, so I'm going to measure it to be 2 inches. So 2 inches would be from the end of the protractor to where my thumbnail is. So 2 inches. Oh, I'm really close, but look at that. I'm going to have to make it flat again. That's going to be the only way that I actually reach. And doesn't that make sense? Because look at this right now. If the whole purple stick is 5, right? This whole thing here is 5. The green piece is 3. That means this little piece right here is 2. And that just makes a straight line, a flat line, right? So 2 doesn't actually work. It's too small. However, if it was a little bit bigger than 2, I think it might work. What if I had a 3 inch, a 3 inch, and a 5 inch? Let's try that. Put the camera down here so I have some blank space. So if I came in here with another 3 inch, yeah, that works. I can do it. All right, so let's add to our list here. Hang on, I gotta get rid of some of this. Okay, so in our doesn't work column, we had 1 inch. We also added 2 inches, but then we found out that 3 inches does work. Okay, so, obviously if 3 inches, 4 inches, and 6 inches work, then I'm sure we could assume 5 inches would work. Anything in between those is probably gonna work, wouldn't it? Why not? If 3 inches work and 6 inches work, then I would imagine 5. How about 7 inches? Do you think 7 inches would work or wouldn't work?
I think it would work.
I've got 1 vote for wood. This one I can try. So let's see, it was a 3 and a 5. Let me just measure if I have a 7. I might. The other thing that complicates this is, oh, why don't I put 2 together to make 7? I could do that. Maybe. Isn't that going to be different colors? Oh, that's all right. Okay, let me get this one color down here. Okay, so, oh, and at least they're kind of close in color. This is my, that's my 7-inch one now. So I had to put a little 1-inch extender. So we'll try with the 3 and the 5. Can I actually make one? Let's see. Let me zoom out here. Whoop, whoop, whoop. All right, so I have the 7-inch down here. I'll try and get it all on the screen so we can see end to end. There we go. Click this one in. Okay, moment of truth. Does 7 inches work? It does. How about that? So 7 inches, let's put it in the does work column. Okay, so let's kind of take a look because now we have a really good sort of, we have it laid out. So let's start at the smallest we have. 0 inches didn't work. 1 inch didn't work. 2 inches didn't work. But once you hit 3 inches, now it works. 3, 4, 5, 6, 7 works. And now over here to 8, it doesn't work. So, gosh, this would be super annoying to have to do every single time. There's got to be one way that sort of sums all of this up. So, I'm wondering if any of you could come up with a rule that would tell me what numbers would work and what numbers wouldn't work. And I'll give you a hint. 3 and 5 have a lot to do with what the rule needs to look like.
Anything less than 3 doesn't work, or 3 plus 5, which is 8, so anything less than 8 works.
You're very close to having it spot on. You're super, super close. You're actually 100% right with the 8 part. So when you add 3 and 5 together, you get 8, right? And we determined that 8 doesn't work because it would make a straight line. But if I had something less than 8, like 7, then it would work. Do you think 7.5 would work?
Yes.
I think so too. 7.5 will probably work. In fact, give me just a minute and I think I have a piece that is that length. Or if not, maybe I can make it be that way. I want 7.5. Well, that's 6. I want a 1.5 piece. So maybe if I put this back here, does that work? 6. It's too big. I'm gonna use 2 of this. Oh yeah, 2 of these small ones that might work. No, that doesn't work. That was silly. I'll just do it with a ruler. Oh, but I don't have a ruler long enough, so I can't do that. Let's try with this one. Oh, I might actually have it. 6 is right there. All right, close enough. So what I have here, this bottom side is roughly 7.5. I think it's actually a little bit bigger, but let's see if this works. Ooh, I have to stretch it, but it does work. I do get this very narrow triangle, but 7.5 is a winner. So looks like Haley is spot on. Basically, I have to have anything that's got to be, if I add my 2 sides together, 3 and 5, I get 8. I can't have 8, but I can have less than that. Right? So that's half the battle. But then I have to be careful because I can't go too small, right? I went too small and then I got 1 and 2 here. So let's jot down what we know already. The third side must be less than the sum
Mr. Orlick speaking. Hi.
of the two sides.
Yes. Yep. Hi. Kira, you dismissed.
But also must be, so there's another part to this, right? Because we can't go too small. 1 inch and 2 inch didn't work, but 3 inches worked. So Haley, what did you say about that other side?
Anything less than 3 doesn't work.
Yes. Okay. So you're kind of right. I think we just have some unique numbers. Here, I'm going to tell you what the rule, unless anybody has another guess for what the rule is for the other side. So on one end, you have to have a number that's less than the sum of these two, but you can't go too small. And the way that you know you're going too small is if you take these two numbers and their difference. So the difference between 3 and 5 is 2. So I have to have something bigger than their difference. Okay, so the third side must be less than the sum of the two sides, but also must be greater than their difference. And hopefully you understand why that is with all these little triangles I've been making you. Okay, so let's see if we can come up with an answer to the original question. So a triangle with 3 inch and 5 inch sides, oops, can have a third side. So I'm going to write it in words, and then I'm going to show you symbolically how we write this. So it can have a third side. We said it had to be what? Less than 8? And greater than 2 inches, because that's the difference of 3 and 5. So I need less than their sum. So if I add 3 and 5 together, their sum is 8. But then I need to be greater than their difference. The difference of 5 and 3 is 2. So an easy way to write this is as follows. So it's got to be greater than 2. We always start with the smallest number. You got to be greater than 2 and less than 8 at the same time. So we use that inequality notation to set up this range, where x is the length of that third side. So now that you know this, now finding the range of possible values for the third side is actually really easy. So let's do a whole bunch of them together. I'll give you a second to just finish writing this down if you haven't already. Okay, let's flip the page and we'll try some. Okay, I'm going to make a little chart here. Let's do triangle side lengths, range of values, or third side. Okay, so let's just put in our list. We just did 3 and 5, and our range was had to be greater than 2, less than 8. All right. So remember where we're getting these numbers from. The first number is the difference between the two, and the second number is their sum. So let's try, oh, I don't know. I'll just, how about 7 and 15? Because that's my birthday. My husband's birthday was yesterday. It was lovely.
Tell him I said happy late birthday.
I will. He wanted cupcakes, and so we made cupcakes, and my son kept stealing them. Every time we turned around, he had a cupcake. I'm like, where are you even getting them from? I thought he couldn't reach them. He could. He ate so many cupcakes. He's probably still on a sugar high. Anyway, 715. So the range of possible values, the first number, I'm just going to take the difference between the two. So the difference between 7 and 15 is what? 8? So the third side would have to be something bigger than 8. However, I can't go too big. It would have to be less than what?
22.
Yes, thank you. Less than 22. So if I had a third side that was 10 inches, yeah, it would work out just fine because it's in this range between 8 and 22. If I had a 19-inch side for the third side, yep, that's fine because it's within this range. Okay. If it equals 22, is that going to work?
No.
Can I make a triangle out of 7, 15, and 22?
No.
Yes or no?
No.
No, because it has to be less than 22. So equaling 22, that's when you get that flat line. You don't get a triangle. So that wouldn't work. All right, try this one. What if I had side lengths of, I don't know, 6 and 11? Okay, everybody go ahead and get your range. Don't say anything out loud. Just get your range. Everybody write it down. I'm going to call on you at random, so make sure you're ready. I even found a cute little holder for all the popsicle sticks. Here's you guys. Okay, what is my range this time? Let's see who's with me here. James, what would my range be for this? James, I don't know if you're typing.
No, he's thinking.
Oh. Okay, he says he doesn't know. So let's make sure that we're all oh, Haley, I'm not going to pick you though, because I know you know.
Oh, come on.
Sorry. All right, why don't you give me the first number? It would have to be bigger than what?
5.
Yes, because the first number, ladies and gentlemen, comes from the difference between these two. So it's got to be bigger than 5, but it has to be less than what number, Juliana?
17.
Yes, 17. So this number comes from the sum of the two. All right, let's try another one. What if they're the same? What if it's like 5 and 5? Guess what? It doesn't matter. You still operate the same exact way. So it would have to be larger than what value, Vinny?
Let me think real quick.
You said something, but I couldn't make it out.
Give me a second.
Oh, sure.
I don't really know.
I know you don't know because it doesn't take anybody very long to subtract two numbers. So let's see if, Mark, can you tell me? Bless you.
Thank you.
Mark, you there? Okay, we'll start making my list here. All right, let's move on to, did Kira leave? Yeah, she did. All right. Lyric.
Yep.
What would the range of values for the third side be if I have 5 inches and 5 inches? It would have to be bigger than what?
I can't see it. It's dark. I can't see it. Oh, 0.
Thank you. The first number comes by just subtracting the two sides. So I know this third side has to be bigger than 0, which makes sense, right? Because if you have two sides that are the same length. So just check this out real quick. If I had two side lengths, let's just go with these two green ones here. All right, so if I have two side lengths that are the same, to make a triangle, obviously it can't be 0 because then I wouldn't have a triangle at all. But if it's something bigger than 0, it can be really small, right? I do have a triangle there if I connect that third side. So I need something bigger than 0, but it's got to be less than, Dylan, less than what? Dylan, you got an answer for me? I see you there, Dylan. I don't know. Yeah. Do you have an answer? Oh boy. Guys, I really need you to pay attention. It's so even if you didn't pay attention while I was doing the first part, I've done 4 examples right here. The first number comes from subtracting these two. The second number comes from adding them. So 10 is the number I'm looking for here. Let's try this one more time, or as many times as we need to until we start getting these right. How about 8 and 12? All right, so the third side would have to be, Caden, bigger than what?
4.
Thank you. And less than, Colin?
20.
Thank you. Okay, my kids in class are with me. Let's try one more. I have a few more of you to call on. How about 1 and 7? The third side would have to be larger than what, Elizabeth?
6.
Thank you. And smaller than Ethan.
Is it 8?
Yes, it's 8. Okay, so I feel a little bit better now. So remember, the first number, I'll even put it in here. First number is the difference between the two. Difference between two sides. And then the second number is simply the sum. All right, so, and it's always, the inequality is always written the same way, the smallest number first, and then you have the symbols this exact same way, X in the middle, and then your larger number over here. All right, so these style questions could be asked a little bit differently. I could give you 3 side lengths and say, hey, could you make a triangle out of these, yes or no? So let's try some like that. And then that's pretty much it for today. So the question is, can you make a triangle out of these sides? So let's just try, I don't know, 6, 7, 8. Would that work? Feel free to send me your thoughts in the chat. If you could make a triangle out of a 3 side lengths of 6, 7, and 8. Notice, I don't care what kind of a triangle. I'm not looking for necessarily right, obtuse, or cute. I don't care. I just want to, can I make any triangle out of 3 side lengths of 6, 7, 8? I got 1 vote for yes. Keep them coming, people. Keep them coming. Oh, 2 votes for yes. And, I didn't mean to tell you what they were voting for, but yes, they are correct that it's a yes. Now, here's how you know. You can take any 2 sides, it doesn't matter which 2 sides you're looking at, and think about what the range has to be for the third side. So if I just ignored the 8 for a minute, and I just looked at the 6 and 7, the possible range of values for the third side has to be bigger than 1, because I'm going to take the difference, right? And then it has to be less than their sum. So if I add 6 and 7 together, that's 13. So the third side has to be between 1 and 13. And obviously 8 fits the bill. Okay, so you can always do that. And just take any 2 sides and figure out what the range is for the third and see if that third one actually fits. Okay, so let's try another one. What if, so this was example 1. Let's try example 2. What if I had 4, 2, and 6? Could you make a triangle out of those 3 sides? I got one answer. Keep them coming, people. All right, so let's look. If I just take the first 2 here, I would need a third side that's got to be bigger than their difference. So if I subtract 4 and 2, I get 2. So the third side has to be bigger than 2, but it has to be less than their sum. So 4 plus 2 is 6. So does 6 actually fit here? Because remember, my number has greater than 2, which it is, but it also has to be less than 6. Is 6 less than 6? No. So this actually doesn't work. It's got to be in this range. It's got to fit in between 2 and 6. And 6 is here, so that does not actually work. So we're going to go with no. All right, let's try another one. What if I had 7, 7, and 3? Could you do that? I'm going to call on you at random, so make sure that you are ready. 7, 7, and 3. Can you make a triangle out of those 3 side lengths? Okay, I am going to call on, let's see who gets chosen this time. Chase, can I make a triangle out of 7, 7, and 3?
No.
I actually can. So here's my test. I take any 2 sides. I always pick the first 2, but you can pick any 2. So my range here, the difference has to be 0, right? So it's got to be something bigger than 0, but it has to be less than their sum is 14. So I need a number that's going to be in between 0 and 14. Is 3 in between 0 and 14? Yes. So this does actually work. Had to be bigger than 0, less than 14. Okay, let's try another one. What if it was 10, 3, and 6? Can you make a triangle out of sides 10, 3, and 6? Be careful. Okay, Olivia, what do you say on this one? Can you make a triangle out of 10, 3, and 6? I think she just said in the chat, yes. All right, so let's see. Let's try it. Take two of the sides, right? So I just take the first two, 10 and 3. I want to imagine I didn't know that that was a 6. So just like we were doing up in the chart, all the way up here, right? We found this range by finding the difference in the sum. So I'm going to do that. So there's my first two sides. The difference between those two is 7. So I need a number that's going to be bigger than 7 and less than their sum. 10 plus 3 is 13. So then I got to ask myself, well, does 6 fit into this range? No, right? So this one actually would not work. 6 is not in between 7 and 13. So no is my answer on that one. Okay, guys, does this kind of make sense? Let's do 2 more examples because I feel like we need a little bit more. I'm trying to think where I could fit them in without going on to a third page. I'll just squeeze it in right here. So same question. Can you make a triangle out of these 3 sides? If your sides are, so this is example 5. Let's do, I don't know, 7, 9, and 12. Can you make a triangle out of these 3? Oh, how convenient. I have 2 people left to call on. And I'll do 2 more examples. All right, out of 7, 9, and 12, can you make that into a triangle? Megan, yes or no?
Yes.
I agree. So I'm going to take the first 2, 7 and 9. The third side would have to be, their difference is 2. So it's got to be something bigger than 2 and less than, if I add 7 and 9 together, I get 16. So then I just ask myself if 12 fits into this range. Yeah, it does. 12 is in between 2 and 16. So yes, this works just fine. Okay, and my last example, Alex, this one's gonna be yours. So let's do, how about 4, 10, and 6. Can you make a triangle out of those 3 values?
Yeah.
I'm sorry, what'd you say?
Yes.
You say yes.
Oh, no, because
No. Unfortunately, it's gonna be a no. And here's why. Take your first 2 numbers, 4 and 10. The difference is 6. So I need a number bigger than 6 and less than 14. So 6 is not bigger than 6. So that's why it doesn't work. It's got to be in between the 2. Okay, so it's got to be bigger than 6, but less than 14. So this one's actually not going to work. All right, everybody. So those are really the 2 different ways that I could ask you these questions. You do have a homework assignment, and I believe it is on CUDA. So I'm going to shut this off. Whoa. Give me just a second. I'll make it live for you. I'll do 1 or 2 of them, and you could give these a shot. Whoa. All right, so let's go to, stop the share. We're gonna get this out of the way. And let's check out tonight's homework. Here it is. Let me post it for you.
Is this on CUDA or Delta?
It's going to be on CUDA.
Okay, thank you.
No problem. Versus All right, so the homework should be live for you now. I'm going to do just maybe one of each type. So if you need some additional help, watch me. If you don't, then that's fine. Go ahead and do the assignment. There we go. All right, so you're gonna have one set of questions that ask you just like this, just like we did in the beginning. You have these two sides. What's the range of possible values for the third side? So remember, you're just gonna take the two numbers, whatever they are. The first number all the way on the left has to be their difference. So the difference between 12 and 7 is 5. So I'm already down to choices C or D. And then the next number has to be their sum. So if I add 12 and 7, that's 19. So it's got to be choice D over here. I need a number that's greater than 5 and less than 19 at the same time. So for example, 10 would work, 11 would work, 6 would work. Would 5 work? No, because 5 is not greater than 5. It has to be in between this range, 5 to 19. All right, so that's the first style question. And then you get some, just like what we were just doing. Here's 3, tell me yes or no. Can you make a triangle out of these? So it doesn't matter which two sides you choose to work with. I just always pick the first two. So if I pick the first two, 12 and 7, well, that's funny. Isn't that what it was in number 1? Oh yeah, 12 and 7. Look at that. I already know the answer. It's got to be in between 5 and 19. So remember where I'm getting that from. I have to subtract these numbers. I get 5 and I have to add them and I get 19. So then I just check, is that third number in that range? Is it greater than 5 and less than 19 at the same time? Yes, 15 is in between 9 and 15, 9 and 19. Sorry, 5 and 19. Oh gosh, so many numbers. So subtract the 2 to get your first number, add them to get your second, and then just see if this third one is in between those two values. And it is. So yes, I can definitely make a triangle out of these 3 side lengths. I'll do one more, why not? So if I'm looking here, 7, 11, and 4. So just take the first 2, subtract them, you get 4. Add them, you get 18. I need my third number to be between 4 and 18. It's got to be bigger than 4. It can't be 4. It's got to be bigger than 4, less than 18. So 4 on the nose does not work. Think about it. If you had 7 inches, 11 inches, and 4 inches, 7 plus 4 is 11. So you're just going to get a straight line. It won't turn into a triangle. It's just a perfectly straight line. No triangle here. So that one's got to be a no. Okay, so that is the homework. Let me stop